Every important increase in aircraft performance has brought with it a new set of challenges to find a way for the pilot to exit from the airplane in an emergency. The highly developed F-102A weapon system has posed a special challenge. This is now met by the Canopy and seat ballistic systems into which has been integrated the U.S. Air Force Global Survival Kit. This film is designed specifically for pilot and crew orientation in the ballistics ejection system and in the installation, operation, and servicing of the Global Survival Kit. The importance of learning escape and survival procedures cannot be overstressed. In an emergency, there is no time to correct errors, no time to remember half-forgotten facts. Your knowledge of this system may mean the difference between personal safety or something like this. Every FTF-102 delivered to the Air Force is now, or will be, equipped with a complete global survival kit. The kit is placed in the ejection seat, where it becomes an integral part of the airplane. Under the cushion, the global survival kit consists of this fiberglass container, which is divided into two compartments. The aft compartment, under this parachute support pad, houses the automatic oxygen regulator and the emergency oxygen supply. This is a complete emergency oxygen system in itself, and also contains a common manifold through which the ship's oxygen system is automatically fed under normal conditions to provide proper mask and suit pressure. These two oxygen bottles will take over to supply emergency oxygen for a 10 to 15-minute period. Attached to this aft compartment is the personal leads assembly, containing the electrical leads, as well as the helmet, bladder, and capstan outlets. This green apple, or emergency oxygen manual release, is for in-flight emergency use. We'll explain how it works later. Moving now to the forward compartment of the Global Survival Kit, we see the two parachute harness connectors, which are snapped on to the accessory rings of the parachute harness. This is the harness release lever, and this is the emergency release handle. As you can see, the opening of the kit is a simple operation. The forward compartment is designed to accommodate items for survival on land or sea. Except for the life raft and the reflector on the underside of the lid, all items in the forward compartment are encased in a rubber-covered, waterproof nylon bag. Mandatory items are a two-way radio, two distress signals, mirror, a whistle, matches, the manual, and other survival items dependent on the geographic and climatic area in which the kit is used, in accordance with applicable directives. The life raft, for example, would be packed if overwater operations were planned. The pilot should make it a point to become familiar with each item in his survival kit and be proficient to the point of perfection in its use. Now let's examine the pilot escape system. Both the kit and ejection system are involved in the split-second sequence of events that has just helped this pilot escape from the aircraft. But let's go back and find out exactly what happened and why. There are two ways for the pilot to jettison his canopy. Either by pulling this handle on the forward face of the left armrest, or by raising, with a force of about 20 pounds, either one of the ejection control handles located on each armrest. Either of these methods will arm the seat ejection system, but it should be understood that the pilot is in no danger of being involuntarily ejected. The seat cannot be ejected until a pilot grasps either or both of the seat ejection triggers and squeezes. The pilot can be assured that the force of a hard landing will not detonate the armed seat ballistic system. Now let's examine what happens when the canopy is jettisoned. Static tests have proven that the canopy travels aft in an arc until the hinges shear. It then rises 6 to 8 feet and travels aft 8 to 20 feet from the cockpit. The pilot is in no danger of being struck by the jettisoned canopy. Now let's study the canopy jettison and seat ejection ballistic system from the inside. When the pilot lifts either ejection control handle or pulls up the canopy jettison knob, mechanical linkage pulls the pin that fires the first ballistic charge in the canopy ballistic system. This charge is called an M3 initiator. Firing of the initiator expels gas through the ballistic system hose to fire an M3 thruster. Now, two things happen when the ballistic charge in the thruster is fired. The plunger is driven out to disengage the canopy latches, and at the end of plunger travel, the gases are ported through this outlet into the ballistic system hose to fire the M5 initiator. Firing of this initiator, in turn, fires the ballistic charge in the canopy remover. As the canopy is jettisoned, mechanical linkage, or an attached lanyard, pulls the pin that fires a second M3 initiator located in this position. Gas pressure from this initiator travels down the ballistic hose to operate an M1 exactor. Here's a closer view of what happens when the exactor is set into operation. Now, the exactor is not a ballistic charge. It is essentially a safety locking pin. Gas pressure from the M3 initiator enters through this inlet and pushes the exactor piston back. This removes the safety pin from another M3 initiator, and the seat ejection system is armed. But again, let's repeat something worth remembering. The pilot is in no danger of being involuntarily ejected. The only way the seat can be ejected is for the pilot to squeeze this trigger. All right, let's have the pilot squeeze the trigger and see what happens. First, mechanical linkage pulls this pin to fire the M3 initiator, the one from which the M1 exactor pin has just been removed. Gas from the M3 initiator fires the M3 catapult, or the new Mark I rocket catapult, which ejects the pilot's seat. The kit is disconnected from the plane by this lanyard as the seat starts up the rails. The emergency oxygen supply in the kit is automatically actuated at this point. As the seat leaves the plane, a lever trip triggers an M12 initiator. 1 second after this M12 fires, gas pressure unfastens the pilot's lap belt, and the pilot separates from his seat. The survival kit remains attached to the pilot's parachute harness. Now let's follow the pilot's descent to where, at 14,000 feet altitude, an automatic aneroid timer deploys the parachute. Incidentally, if ejection is below 14,000 feet altitude, the parachute will deploy immediately. After the parachute opens, the pilot should remove his faceplate. Then pull the emergency release handle on his survival kit. This disconnects the kit from the personal leads, as well as from his parachute harness fittings, and causes it to separate and drop away, still attached by a lanyard to the parachute harness. If he is over water, he now inflates his life preservers. The life raft in the kit inflates automatically and falls 15 feet below the pilot. The kit itself drops 25 feet below the pilot, thus landing before him and relieving the parachute of its weight. Parachute jump tests have been made carrying the kit all the way to the ground, but since it weighs approximately 42 pounds when fully packed, a pilot can lessen the force of his ground impact appreciably by allowing the kit to drop away and land first. Now let's examine in more detail removal and reinstallation of the kit by the technician. With proper canopy safety precautions taken, the next thing to check before entering the cockpit is that the 3 canopy jettison and ejection seat initiators are safetied and the ejection seat armrest safety lock pin is in place. Now you may begin removal of the global survival kit from the airplane. To provide slack in the ship-to-kit leads, the seat is lowered to its lowest position. Then the technician lifts up the rear of the global survival kit so that he can separate the ship-to-kit disconnect. Removal of the safety pin allows the thumb button to be depressed and the disconnect fitting to be separated from the kit. He replaces the safety pin in the thumb button shaft, installs the dust cover on the disconnect fitting, and now is ready to lift the kit from the seat by grasping the parachute attachment straps. Once the global survival kit has been removed from the seat, specially trained personnel proceed with inspection and, if necessary, servicing and repacking. Specific servicing procedures are covered in applicable publications. Before he begins installation, the technician examines the forward part of the survival kit to make certain that the emergency release handle is down and properly safetied, that the release pin is installed in the emergency release handle, and that the drop line is secured to the left-hand harness attachment fittings on the kit. He then determines that the notched blade end of the green apple is connected, that the kit-to-man disconnect lock mechanism is engaged, and that the red index marks are lined up. Following this, he checks to be certain that the fabric enclosure of the personal leads assembly is zipped up with the strap at the top. He also makes certain that dust and pressure caps have been installed on the bladder, mask, and suit capstan outlets. He then opens the aft compartment to make sure that the emergency oxygen release pin is connected to the bayonet fitting and that the oxygen pressure gauge registers at least 1800 psi. He next looks at the disconnect fitting on the bottom of the kit. He checks its electrical connector for bent pins and condition of the O-ring. The disconnect fitting should be clean and free of nicks. This completes the pre-installation inspection of the kit. In the cockpit, the technician makes sure the pilot's seat is lowered to its lowest position. He lifts the ship-to-kit disconnect fitting through the hole in the seat and checks the disconnect fitting in the ship the same as he did on the kit. The ship's portion of the fitting must be attached to the airplane structure by its lanyard. Satisfied that the fitting is in order, he then removes the safety pin from the thumb button on the lower half disconnect, depresses the thumb button, and temporarily installs the safety pin on the opposite end of the shaft. Experience has proved that this procedure will make it easier to mate the connections. Now he lifts the kit into the cockpit and places it on the seat, tilting it up on the forward edge. He pushes the disconnect fitting into the ship-to-kit receptacle underneath the survival kit and removes the safety pin from its temporary position, allowing the thumb button to snap out and engage the fitting. The safety pin is then installed in the hole closest to the thumb button. After checking to be certain that the lanyard, oxygen hose, and electrical wiring will not restrict seat operation or will be chafed by surrounding structure, he lowers the kit into the seat. He then places the personal leads assembly in an upright position. The global survival kit and the canopy and seat ballistic system are now checked and ready. Later, before the pilot enters the plane to make his pre-flight checkout, the technician removes the safety lock pins from the two M3 initiators and the M12 lap belt initiator. While entering the cockpit, the pilot double checks to see that the safety lock pins are removed from the initiators. But he does not yet remove the safety lock pin from the ejection seat armrest control handle. Removal of this pin is the last step of his pre-flight checkout. He checks the lock wire that holds down the emergency release handle, then makes certain that both harness attachment wedges are locked into their assemblies. He connects the bladder hose of his partial pressure suit to the bladder port on the side of this T-fitting in the personal leads assembly, and the suit's capstan hose to the hose connection. The hose from his helmet faceplate is connected to the hose extension on the T-fitting, and the communication and faceplate electrical leads are hooked up. Now, to clarify another condition, we will show the procedure for hookup when flying with the A-13 mask. Before the pilot can use the A-13 mask, the reducer adapter must be attached to the hose extension on the T-fitting. The pilot inserts the A-13 mask hose connector into the reducer adapter. The bladder and capstan ports on the personal leads remain capped. Flights with the A-13 mask should not be made at altitudes over 43,000 feet. Decompression with the A-13 mask above 43,000 feet could be fatal. If decompression occurs above 30,000 feet, descend immediately to at least that altitude. The pilot in the pressure suit next switches on the ship's oxygen to be sure the system is functioning properly. Pressure will become apparent inside the helmet. The pilot then presses the Press to Test button on the front of the Global Survival Kit to test his oxygen system. The button should be held down for about 10 seconds until additional pressure builds up in his suit and helmet. When the button is released, it will return the pressure to normal. Concluding these tests, the pilot turns on his heater control until the faceplate begins to feel warm. Checks his communication equipment and secures his shoulder harness, parachute automatic opener lanyard, and lap belt. He then hooks up his low-altitude parachute deployment capability, as outlined in the flight manual. The technician then makes a final check of the pilot and cockpit area. Now, as we said previously, the pilot completes his checkout by removing the safety lock pin from the ejection seat armrest control handle, and can now take off with confidence that the ballistic system and global survival kit are ready. During normal flight conditions at high altitudes, the ship's oxygen system supplies breathing oxygen and suit pressurization. It cannot be stressed too strongly that the global survival kit used in the 102 is primarily for use with the pressure helmet and the partial pressure suit. Oxygen regulators of the type used in the survival kit were originally developed for and proven by such special projects as the Bell X-2 speed and altitude flights to 126,000 feet and the altitude chamber tests to 198,000 feet. Normal flow of the ship's oxygen through the oxygen regulator in the global survival kit follows this pattern. Ship's oxygen at approximately 70 psi enters through the ship-to-kit disconnect and is routed via the check valve through the regulator, which delivers the 100% oxygen to the helmet and suit bladder. In the event of loss of cabin pressure, oxygen is also delivered to the suit capstan automatically. Now let's see what happens when the pilot realizes that emergency oxygen is necessary. For instance, if the ship's supply is expended or contaminated. He actuates his emergency supply by pulling the green apple and then turns off the ship's supply. Since the emergency supply will last only 10 to 15 minutes, the pilot must decide immediately whether there is time to complete his mission or whether he must descend without delay. Pulling the green apple pulls a cable which withdraws the emergency oxygen release pin from the shutoff valve. Oxygen at 1800 psi is released from the bottles to the pressure reducer, which cuts down the pressure to approximately 50 psi. The emergency oxygen is then routed via the check valve into the regulator and to the pilot's suit and helmet. The difference between the 50 psi of his emergency system and the 70 psi of the ship's system would not be noticeable to the pilot. However, the pilot should be aware of a rather unusual circumstance in which the difference between the 50 psi of his emergency system and the 70 psi of the ship's system can be important. If he should accidentally pull the green apple while the ship's system is functioning normally, there will be no loss of oxygen from the emergency bottles, since the stronger pressure of the ship's system will prevent the emergency system from operating. But remember, if the pilot suspects contamination of the ship's oxygen system, he must pull the green apple and turn off the ship's supply to allow the emergency oxygen system to function. In the event the pilot ejects, the lanyard attached to the ship-to-kit disconnect fitting automatically separates the connection between the survival kit and the aircraft, and at the same time activates his emergency oxygen supply. As we have already noted, the emergency oxygen supply from the global survival kit continues to supply the pilot with breathing oxygen and suit pressure while descending. But we didn't follow the descent down to surface contact, in this case a water landing with his kit equipped with a life raft. The pilot would be wearing underarm life preservers, which he inflated after releasing his survival kit. On surface contact, he operates the parachute canopy release, then pulls the raft to him. He climbs into the raft and may, if necessary, with a hook blade knife, cut the suspension lines attached to the right risers. By remaining in his harness, the pilot is assured of retrieving his kit. In descending over land, he pulls the emergency release handle to let the survival kit drop and make contact first, thus relieving the parachute of its weight. The pilot, being uninjured, can begin to utilize his survival kit as soon as he is disengaged from his parachute. The International Orange Flying Suit is still undergoing experimental tests and is not a standard Air Force item. When the pilot is injured, he can still draw the kit to him by means of the drop line so that he can utilize the survival equipment. All of which re-emphasizes the previous point that the pilot must become proficient to perfection in the use of each item in his survival kit. We have seen how the pilot ejects. Now, what about a quick egress from the airplane under emergency conditions on the ground? The pilot releases his lap belt and pulls the emergency release handle. This operation separates the kit from the pilot. The life raft does not inflate, and the lanyard is not attached to the parachute harness. But under normal conditions of unhook and egress of the pilot from his airplane, he releases his canopy, and, as it is safetied by his crew chief, safeties his ejection armrest control handle, shuts off his ship's oxygen system, removes his faceplate, disconnects his communication and faceplate electrical leads, disconnects his helmet and pressure suit hoses, unhooks his shoulder harness and lap belt, detaches the survival kit quick disconnect from the accessory ring of his parachute harness, and then is ready to leave the ship. This pilot, like so many others in the Air Force, knows that he can depend on the emergency escape system of his aircraft, as well as on the global survival kit with its integrated oxygen system. And he knows that behind the system itself stands a record of satisfactory performance in the many special projects for which it was originally developed. The survival kit has a proven margin of safety, but no margin of safety is so great that it cannot be reduced to the vanishing point by lack of knowledge and failure to observe proper procedures. The emergency escape and survival system of the FTF-102 is, in the final analysis, just as safe and dependable as you make it.